Okay, so in the previous podcast, we ran a one-way ANOVA test on this very same data set using Excel, but I did not show you how to use the graphing calculator, so I did want to revisit this problem. The following data represent the weights in grams of pennies minted at the Denver Mint in these various years, 1990, 1995, and 2000. And in the previous podcast, we verified that the requirements to perform a one-way ANOVA are satisfied. What I want to do now is, and I'll recall that, remember the null, so in the research hypothesis, so the null is mu1 equals mu2 equals mu3, that the three population means are equal. The H1, or the research hypothesis, is that at least one mean significantly differs from the other. So at least one mean differs from the others. Okay, so in the previous podcast, we ran through that test. I just wanted to do a quickie podcast of, how do I do that on my graphing calculator? So it's very simple. So I'll show you what I did. I went to Stat, Edit, and I put the data. You can see it. I put let me make it bigger. In L1 and L2 and L3 respectively. Okay? And I did want to remind you, how the requirement that the largest sample standard deviation has to be less than twice the smallest sample standard deviation? Recall that if I wanted to get all the sample standard deviations, remember you could always go Stat, Calculate, one variable statistics, and hit Enter. If you just hit Enter, it'll give you the CS.022, that's the sample standard deviation of the first group. And you could do that for each group respectively. Okay? So one variable stats, and then I could tell it L2 and 0.024. That's the sample standard deviation for the next group, which happens to be the largest. And then Stat, Calculate, one variable statistics, I can tell it L3, and the smallest sample standard deviation for the third group, the year 2000 data, is 0.014. So twice 0.014 makes 0.028, and that's still larger than the largest sample standard dev. So that one of the requirements to perform the one-way ANOVA is that they're coming from populations that have the same variance. And your author is saying rather than run an F-test, just go by that general rule of thumb. So that's satisfied. And you can refer back to the other podcast on that as well. I wanted to focus on running the actual test, so let's slide over to Test. Let's slide down to ANOVA. Okay, and it's pretty straightforward. You just tell it L1, comma, L2, tell it all the lists of data that you're dealing with, comma, L3. Hit Enter. And it produces the very same F-test statistic, 1.11, and p-value, 0.34. And just like we did in the last podcast, since p, which is equal to 0.34, is greater than alpha level, we fail to reject H0. And basically that means we do not have enough evidence to support the research hypothesis, so there's not enough evidence to say that at least one mean significantly differs from the other. And again, if you refer back to the previous podcast, you'll see that it's the very same F-test statistic and p-value. So if you're in my class and you're taking a final, you're using your graphing calculator, but a lot of people out there use Excel. So, okay, good luck.